Hello again everybody, and welcome to video 18 of my Linux Commands for Beginners tutorial series. And in this video I'm going to be wrapping up my discussion on permissions, and this continues directly where I left off in the last video, continuing with the chmod command that we use to change permissions on files and folders. So just as a quick refresher, the syntax we used in our last video is something like this. So to change permissions in a file or folder, you'll type the chmod command, space, and then whether or not you are changing permissions for the user, for group, or for other, and then a plus sign if you're adding a permission, or a minus sign if you're taking it away, and then which permission you want to add or take away, for example, read, write, execute, or any combination of those, and then a file or folder to work with. So that's basically the syntax that we used in the last video, but there is a numeric system like I mentioned, and that's what this video is going to be about. So let me pull up my list of files again so you can see the sample files that I have here to work with. So as you can see, my permissions are all over the place. Now here we have case test as my first file, which is the file that I've been using for, I don't know why, I've been using this quite a lot. But anyway, I'm going to change the permissions of that file with the numeric system instead. So chmod 777 case test. If I execute that, notice what happens to the permissions. Now everybody has everything. User, group, and other all have read, write, and execute permissions. So why is that the case? What do those numbers actually mean? Well, that's what I'm going to go over right now. So here's how the numeric system works. Each type of permission, whether it's read, write, or execute, has a number that it's worth or that it's associated with. So read, which is normally R, can also be designated with the number 4. Write, which is typically W, can also be associated with the number 2. Execute, which is X, can also be represented by a number 1. So again, read is 4, write is 2, execute is 1. So when I'm using the numerical system, notice how I used 3 numbers. The first number is user, the second number is group, and the third number is for other. So I gave user a 7, group a 7, and other a 7. Now how did I arrive at 7? Well, even though these permissions all have their own number, you can add them together. So like I said before, read is 4, write is 2, execute is 1. But if you add all 3 numbers together, read, which is 4, plus write, which is 2, plus execute, which is 1, equals 7. So by giving each category permissions a 7, I'm basically saying that I want each category to have everything. So let me illustrate this a little bit more clear so you can understand what I'm doing. Now I mentioned that read is 4, so chmod 444 case test. Watch what happens. Now each category has simply read. That's all they got, because read is number 4. So since I only gave each number 4, then each only got read, because that's what read is. Read is 4. So likewise, if I would have done instead 222, which is write, now everyone will have write permission to the file, but not permissions to read it. Now I understand these are crazy permissions and nobody's going to use any of these, but it's important that I do it this way so that you understand what I'm talking about. So just the same way, chmod 111, that gives everybody execute. Now you can do this any way you want. Now for example, if I do 100, for example, instead, here's what happens. Now the owner of the file has execute permissions, but everybody else has nothing. Group has nothing, other has nothing. So that's because I use zeros. So again, the first character is the user, the first digit is the user, second digit is group, third digit is other. So if I was to change it, for example, to 110, you probably guess what's going to happen, right? And you're exactly right. So I gave the first 2 categories of permissions a 1, which is execute. Now you can add them together. So say for example, I want to give user Let me start over here in the command to make it better. So let's say I want to give user, I want to give them read and write access. Well, read is 4, write is 2, so that's 6. There we go. And I want to give group, I only want to give them read, so I'll give them 4. Other, I don't want to give them anything, so I'll give them 0. And then that's the name. Then I type the name of the file I want to manipulate. See what happens. There we go. As you can see here, the owner has read and write. Group only has the read permission set. Other has nothing. Likewise, if I was to give group 6 and still give 0 to other, then you can see what happens. The user has read and write. The group has read and write, but other still has nothing. Now, before I used 7. Again, 7 is everything because execute is equal to 1. So if I add 1 to the first digit, for example, to make it a 7, watch what happens. Now the owner has read, write, and execute, group has read and write, but not execute, and other has nothing. So that's why when I did 777, that gave everybody everything, because read, which is 4, plus write, which is 2, plus execute, which is 1, equals 7. So I'm giving everybody everything. So you can manipulate this any way you want. So for example, you can give everybody read, so 444. You can give a user full access and everybody else nothing, 700. Or 722, which is read and write and execute for user, and the 2 is just simply write. So everybody has just the W, excuse me, the group has W, other has W, and so on. So basically you can modify that any way you want. So again, chmod, we'll do 777, and we could also do an asterisk if we want to give everybody everything. I'm probably going to get permission denied though. Yeah, because one of the files is owned by root, and of course that's another important thing. I think I mentioned this in the last video, but if you are not the owner of a file, you have to use sudo, and of course then it'll work just fine. Now everybody has literally everything, so that's not very practical because everything is wide open, but you get the point. And once you get the hang of this method, the numerical way of changing permissions, I find it just a lot easier in my personal opinion. So one more time I'm going to go over the syntax. chown, a number for user, a number for group, and a number for other. So 3 numbers is what you need to come up with. Then the name of the file. And you don't have to give everybody everything. 0 is nothing. So that's read, write, and execute for user, and then nothing for group and nothing for other. Or you can give read, write, and execute for user and group, or you could just give read, which is 4, to group, or and so on. So basically, again, 4 is for read, 2 is for write, execute is 1, and you can add those up any which way you want, and you need 3 numbers, 1 representing user, 1 representing group, and 1 representing other. So that's how you change permissions using the numerical system. Now I hope that made sense. It was a little bit hard to explain, so hopefully I did a good job. Now this video actually concludes my videos regarding permissions. There are more advanced stuff relating to permissions. In Linux, there's always more advanced stuff. But honestly, this is all you need to know for now. You should have, with the last 5, this video and the previous 4, you should have a firm understanding of Linux permissions and how they work. So when you go around your file system and look at various permissions, now you should know not only what they mean, but how to alter them, as well as how to create groups, how to delete groups, change group ownership, change user ownership. You should understand all of that. So if any of this wasn't clear, just let me know in the comments, and maybe I can slip something in a future video. But for the most part, that's it for now when it comes to permissions. The next video, I'm not quite sure what I'm going to go over next, but it's going to be fun. It's going to be amazing, just like always. So until then, please subscribe to my channel, and thank you for watching.